All right, you guys, we're going to look at the slope of a line. So yesterday looking at graphing linear equations. And today we're going to look at a specific component of the linear equation and of the line, and that is the slope. Think ski slope going up and down a mountain. So slope is a ratio, and it compares the rise, the change in the y-axis up and down, to the run, to the change in the x-axis. So rise going up, run going across horizontally. We use m for the variable slope. So m is the variable used for slope. And you can also think of m multiplier, m mountain, I don't know, come up with your own, but m is used for slope, like in that equation, y is equal to mx plus b. Okay, so m, slope, is the rise over run. And we can find the slope of a line just by looking at a graph. Like this works out pretty easy because these 2 points are kind of close together. So if we were looking at the run, the change on the x-axis, as we have up here in that note, we would be thinking, okay, so it goes from 1 to 2 to 3 to 4. So the run is actually going to be 3. And then how much is it going up? It's going from 1 to 3. So 1, 2, 3. On my graph, it's pretty even, but it goes up 2. Okay? So the slope then is 2 over 3. It's 2/3. The slope of the line goes up 2. For every 3 it moves over. That's one way to calculate the slope of a line. Have the graph, count the change in the run, x-axis, count the change in the y, the rise, and then put it in just like that. Okay, now sometimes it's not a really clean graph where you can count it really easily, and so we have a formula. You got your journal out, get this into your journal, this formula. So m, again, is the variable used for slope. And in this formula for finding slope, we say m is equal to, and you need 2 coordinates to do this. Now, y in subscript 2 minus y, subscript 1, x2 minus x1. Now, those things are just there in the formula to say I've got a first coordinate and a second coordinate. So the first coordinate might be 9, x is 9, y is 13. And all that's saying is this is the first coordinate, x1, y1 is in the first coordinate, okay? So don't get weird. It's not an exponent, nothing like that. Second coordinate could be a -3 and a -5 is the y. And that's just saying second coordinate, x, second coordinate, y, second coordinate. It's just like a little label. It's like putting a sticker on it or something like that to help us see it. So let's use this formula. So we're saying m, the slope of this line that passes through these 2 coordinates, I'm going to use the value y2, rise. So y2, so here's my second coordinate, x, y. So y is a -5. And then minus y1. So minus, here's my first coordinate, y1. So this is xy. So that 13 is the first coordinate. Okay, hang on there. I know this is a lot of information. You're going to need to go back and rewatch this, possibly. And you're definitely taking notes in your journal. Okay. So now we want to know the run. Remember that we do rise over run. I'm even going to write it again right over here. So rise over run, right? X and Y. Okay. So now we're doing the second x coordinate. So again, here's my second x coordinate. So -3. And then I'm going to minus my first y coordinate, which is right here, which is the 9. So -9. And there we go. Now we've created our formula, and the slope of this line, we're going to find it pretty easy, okay? So we've got -5, take away 13 more is a -18. So the change on the y-axis is 18. And then we have a -3, take away a -9 is a -12. Okay, so we've done that. We've organized it in our brain, keeping an idea what's the first coordinate, what's the second coordinate, whichever you choose to be the first or second. I've labeled them here. And then we put it into the formula and we get this. And can you simplify it? You're like, oh, I really want to simplify it. It's a negative divided by a negative, and there's a common factor 6. So yeah, you can simplify this and say the slope is 3/2. So that could be listed as the final slope right there. Negative divided by a negative is a positive, common factor 6. That's your simplified form. Okay. All right, here we go. So I want to point out, again, this is going in your journal. These are slope notes. These are generalizations that are always true. If a line is slanting upward from left to right, I don't know if I'm backwards here on the screen, but if a line is slanting upwards from left to right, that means it will always have a positive slope. You just know that. If a line is slanting downwards, like going down the mountain, then it is a negative slope always. If it's a horizontal line, we say it has a 0 slope. And if it's a vertical line straight up and down, we say the slope is undefined. So pause your head puzzle right there. Add that to your notes. It's good to know. Your practice problems are, 1, find the slope of a line. So just looking at this graph, I've made the points close by. So it's right there. You count over on the x, count up on the y. So find the slope of that line. And then you're going to use the slope formula to use these coordinates to find the slope. So 2 more. You could say this is the first coordinate, x1, y1, and this is the second coordinate, x2, y2. You could do it like that. And yeah, good luck with it. This is tricky, but stick with it. Get your notes in, practice it. It'll click.